Have you ever wondered how life on Earth began? The enigma of our existence is a question that has baffled scientists and philosophers alike for centuries. This conundrum, as intriguing as it is complex, is the subject of our exploration today. We're venturing into a realm where certainty is elusive, and answers are as diverse as the life forms we see around us. The origin of life is not just a scientific query, but a philosophical one too, a riddle wrapped in layers of complexity. It's a quest that takes us back billions of years, to a time when our planet was a fiery cauldron of volatile elements. How did this chaotic world give rise to the first spark of life? How did inanimate matter evolve into living organisms? These questions, while seemingly simple, are anything but. In our quest for answers, we'll be delving into some of the most captivating theories about the genesis of life. These theories, each with its own set of compelling arguments and fascinating possibilities, offer a glimpse into the labyrinth of life's inception. We'll be navigating through this maze, guided by the light of scientific inquiry and the torch of intellectual curiosity. From the depths of the oceans to the farthest reaches of the cosmos, these theories take us on a journey across space and time. They challenge our understanding of life and its origins, pushing the boundaries of what we know and what we can imagine. Can life arise from a primordial soup of organic molecules? Or was it seeded from the stars, brought to Earth by celestial bodies? Perhaps life emerged in the extreme conditions of hydrothermal vents deep beneath the sea? As we embark on this expedition into the unknown, let's remember, the quest for understanding is a journey, not a destination. And as we probe the mysteries of life's origin, we should be prepared to find that the answers may be far more extraordinary than we could ever have envisaged. As we unravel these theories, bear in mind that the truth could be stranger than fiction. Our journey begins with the primordial soup theory, a captivating idea that suggests life originated from a prehistoric soup of organic molecules. This theory posits that around 4 billion years ago, the Earth's atmosphere was a volatile mix of water vapor, methane, ammonia, and hydrogen. This primordial soup was stirred by the energy stirred from thunderstorms and solar radiation, creating a cocktail where organic molecules could form. Now, cast your mind back to the 1950s, when two ambitious scientists, Stanley Miller and Harold Urey, decided to put this theory to the test. They sought to recreate the conditions of the early Earth in a laboratory setting. The duo constructed an apparatus filled with gases believed to mimic the prebiotic atmosphere and zapped it with electrical charges to simulate lightning. Could life have originated from the stars? This is the premise of the Panspermia theory. The Panspermia theory, a concept that has tickled the fancy of scientists and stargazers alike, suggests that life on Earth could have been kick-started by extraterrestrial microscopic organisms or chemical precursors of life. These tiny seeds of life, the theory suggests, could have hitched a ride on comets or meteorites and been delivered to our planet. Imagine, if you will, a comet hurtling through the vast expanse of space, carrying a precious cargo of microorganisms. As it enters Earth's atmosphere and disintegrates, these microorganisms are scattered, eventually finding a suitable environment and sparking the genesis of life as we know it. Yet, the Panspermia theory is not without its controversies. Critics argue that the survival of such microorganisms during the harsh and unforgiving journey through space seems implausible. Moreover, the conditions within a meteorite or comet, subjected to extreme temperatures and radiation, may not be conducive to the survival of life. However, proponents of the Panspermia theory counter these arguments by pointing out that certain bacteria on Earth have been found to survive in extreme conditions, such as the cold vacuum of space or the scorching heat of volcanic vents. Could these extremophiles be descendants of ancient spacefaring bacteria? The question remains open for debate. Nevertheless, the Panspermia theory, while fascinating, does not address one fundamental question: the origin of these microorganisms or life precursors. If life on Earth did indeed arrive from the stars, then where did that life originate? This question, as yet unanswered, continues to mystify scientists and fuels our quest to understand the origins of life. As romantic as the panspermia theory sounds, it merely shifts the question of life's origin to a different location in the universe. Diving deep into the ocean, we encounter the hydrothermal vent theory. This theory takes us to the heart of our planet, to the very bottom of the ocean where sunlight is but a dream and pressure can crush a submarine. Here, life as we know it takes on a different form, thriving in what we would consider extreme conditions. The hydrothermal vent theory proposes that life began in these deep-sea environments, around hydrothermal vents. These vents are like underwater geysers, spewing out hot mineral-rich water from beneath the Earth's crust. They create an oasis of warmth and nutrients in the otherwise cold, dark abyss. It's like stumbling upon a bustling city in the middle of a barren desert. But why would life choose such an inhospitable place to begin? Well, the theory suggests that these vents could provide the perfect conditions for life to form. The heat from the vents could have been the source of energy needed for the first chemical reactions that led to life. The minerals spewing out of the vents could have been the building blocks for the first organisms. It's a theory that turns the traditional view of life's origins on its head. Instead of life beginning in warm, shallow pools on land, it suggests life began in the harsh, alien-like conditions of the deep sea. Yet the hydrothermal vent theory is not without its own controversies. Some scientists argue that the conditions around these vents would have been too harsh for life to form. Others question whether the right kind of minerals would have been present. And then there's the question of how life made the journey from these deep-sea vents to land. Still, the hydrothermal vent theory opens up a whole new perspective on life's origins. It reminds us that life is incredibly resilient and adaptable, capable of thriving in the most unlikely of places. The hydrothermal vent theory, while fascinating, is not without its own controversies. But whether or not it holds the answer to life's origins, it certainly adds another layer to the mystery. As we explore these theories, it's clear that the origin of life is a complex puzzle that we are still trying to solve. We've journeyed through the theoretical landscapes of primordial soup, where life could have brewed from the Earth's own primordial ingredients, stirred and heated by the planet's youthful, tempestuous weather. We've gazed into the stars, contemplating the possibility of panspermia, the theory that life was delivered to our planet from the cosmic beyond, hitching a ride on a comet or meteorite. We've also delved into the ocean's depths, to the hydrothermal vents, considering the idea that life might have sprung from the planet's fiery belly, nurtured by the hot, mineral-rich waters of these deep-sea chimneys. Each of these theories paints a vivid picture of potential life's origin, adding a unique piece to the puzzle. Yet, they all share a common thread. None of them can definitively answer the question, how did life begin? But the absence of a definitive answer is not a cause for despair. On the contrary, it is a beacon of curiosity, a call to exploration. It's a reminder that the universe is a vast, complex place, filled with mysteries waiting to be unraveled. It fuels the spirit of scientific inquiry, driving us to ask more questions, to seek more answers, to probe deeper into the unknown. In the end, the question of how life began may not have a single, simple answer. It may be that life arose through a combination of these theories, or perhaps through a mechanism we have yet to discover. The beauty of science lies not in the certainty of answers, but in the thrill of the quest, in the joy of discovery, in the awe of understanding. The question of how life began remains one of the greatest mysteries of science. Whatever the answer might be, the quest for understanding continues to inspire and drive scientific exploration.
Subscribe for more videos like this. Turn on notification and leave a like to help the channel out. Thank you for watching.